Good day everyone. In this video you will find the solutions for some selected questions for lesson 10.1. We'll start with number 25. In number 25, the question is perform the elementary row operations on the matrix 1 for the augmented matrix 1, 4, 2, negative 3, 6 and 6. The operation is 1/3 R2 should be added to R1. 1/3 of R2 should be added to R1. What's 1/3 of row 2? 1/3 of negative 3 is negative 1. 1/3 of 6 is 1 and is 2, and 1/3 of 6 is 2. So I'm going to add negative 1, 2 and 2 to row 1. So I'm going to add negative 1, 2 and 2 to the first row, and the second row will not change. The second row will remain as it is. So the second row will remain negative 3, 6 and 6, while the first row will change from 1 to 0 because I added 1 plus negative 1. I added negative 1 to 1. Also I will add 2 to 4, which is 6, and I will add 2 to 2 and I will get 4. So the result is 0, 6, 4, negative 3, 6 and 6. Okay, second question. Number 32. It's the same question. Perform the elementary row operations on the following matrix. What's the operation? Negative 4R should be added to R3. So I should multiply the first row by negative 4, and I'm going to add the result to the third row. So let's look at the first row. If we multiply the first row by negative 4, I will have negative 4, negative 20, negative 24 and negative 8. So the result should be added to the third row. So I should add negative 4 to the third row, negative 20 to the third row, negative 24 and negative 8. So, and as we already know, the first row and the second row will not change. So I will write them exactly as they are, and I will change the third row. 4 plus negative 4 is 0. Negative 2 plus negative 20 is negative 22, and negative 3 plus negative 24 is negative 27. 10 plus negative 8 is 2. So this will be my answer. Okay. Number 46. Going to number 46. This number is different from the previous ones. We need to solve the system by using Gaussian elimination or Gauss-Jordan elimination. So it's up to you. We can stop at the Gaussian elimination, or we can continue and use the Gauss-Jordan elimination. The system is 2 multiplied by x minus y, which is equal to 4x plus y minus 40, and 9y equals to 105 minus 3x. So first of all, I should look at the equation or the system of equations. Are they written in standard form? No, they are not. So we need to convert them or write them in standard form. So we do a simple calculations. I will use the distributive property to get 2x minus 2y equals 4x plus y minus 40. This is for the first equation. Here I will add plus 3x on both sides to reach this equation. Now the second one, 3x plus 9y equals to 105, is written in standard form, while the first one is not. So I need to keep doing what I'm doing to equation number 1. So simply subtract 4x, subtract y from both sides. So I will have 2x minus 2y minus 4x minus y equals to negative 40. Do the calculation. I will have minus 2x minus 3y equals to negative 40. Now both equations are written in standard form. Now I can write their augmented matrix. The augmented matrix is -2, -3, and -40, 3, 9, and 105. Okay, if you notice, first row, it's -2, -3, -4. I can multiply row 1 by -1 to change it to positive. Also look at row 2. I have 3, 9, 105. All of them are divisible by, all of these numbers are divisible by 3, so I will divide row 2 by 3 to make it simpler. So now the result will be 2, 3, and 40, and for the second row 1, 3, and 35. Now remember, if I want to use the Gaussian elimination, I need to change this one to 0 and these two numbers to 1, while it's called the echelon form. If I want to use the Gauss-Jordan, I need to convert these two numbers to 1 and this number to 0. Also this number should be changed to 0. Okay, so this is our goal. Is to use the Gaussian elimination method. So what will I do? I will multiply R2 by -1 and add it to R1. Why? In order for the 2 to become 1 and for the 3 to become 0. So I will multiply R2 by -1, R2 by -1, 1 times -1 is -1, 3 times -1 is -3, and 35 by -1 is -35. Okay, now we do the operation, we add them. 2 plus -1 is 1, 2 plus -1 is 1, 3 plus -3 is 0, 40 plus -35 is 5. Okay. Now, what should I do next? Remember, look here. So the result here will be 1, 0, and 5, and the second row will remain as 1, 3, and 35. So what do I do? Now I will use R1 to simplify R2. So minus the operation will be minus R1 plus R2. I will multiply R1 by negative and add it to R2 to get rid of this one, to change it to 0. Okay, so negative R1, it will become 1 times -1 is -1, -1 times 0 is 0, 5 times -1 is -5, and we add them. 1 plus -1 is 0, 3 plus 0 is 3, 35 plus -5 is 30. Now I need to convert this 3 to 1. This 3 to 1. Simply we divide second row by 3 or multiply by 1 over 3. Dividing by 3 or multiplying by 1 over 3 is the same. So what do? I multiply the second row by 1 over 3. The first row will not change, it will remain as it is. The second row will become 0 times 1 over 3 is 0, 3 times 1 over 3 is 1, 30 times 1 over 3 is 10. Now if you look at the matrix here, this is reduced echelon form. This is the reduced echelon form of the matrix, and x equals to 5, y equals to 10. Remember, x, y. X equals, this is x, 1x plus 0y equals to 5, 0x plus 1y equals to 10. So x equals to 5 and y equals to 10. And this is the answer. And let's go to the final question. Number 50. Now we have a system of 3 equations, 3 unknowns. 2x minus 8y plus 54z equals to -4. X minus 2y plus 14z equals to -1. X minus 3y plus 19z equals to -3. Now if you look at the system, it's written in standard form. So directly we write its augmented matrix. 2, -8, 54, and -4. 2, -8, 54, and -4. Here we have 1. 1x minus 2y plus 14z minus 1. So 1 minus 2, 14, -1. Also 1x minus 3y, 14z, and -3. 1, negative 3, 19, and negative 3. So we wrote its augmented matrix. Now we start with the elementary row operation. I wrote it again because it's a new page. Now, if you notice, look at the first row. All of the numbers are divisible by 2. So I will multiply R1 by half, and we will get the result. Second row and the third row will not change. 2 times half is 1. Negative 8 times half is negative 4. 54 times half is 27. Negative 4 times half is negative 2. Now, let's continue. I wrote it again. Okay? Now, this is the result of the matrix after multiplying it by half. Now, what will I do? I will use either Gaussian elimination or Gauss-Jordan elimination method. So, remember, if I want to use the Gaussian elimination, I need to change these 3 to zeros and the diagonal to 1. While the Gauss-Jordan elimination will use the reduced echelon form, and I need to change also these to 0, and the diagonal should be 1. Okay. So now, what's the operation that I'm going to use? I'm going to multiply R3 by negative 1 and add it to R2. Okay? Why? In order to get rid of this 1. So, the first row and the third row will not change. The second row will change. So I will write the first row and the third row as it is, as they are, and then I do the operation on R2. 1, because if I multiply R3 by negative 1, I will have negative 1, 3, negative 19, and 3. Add it to R2. 1 plus negative 1, 0. Negative 2 plus 3 is 1. 14 plus negative 19 is going to be negative 5. And negative 1 plus 3 is going to be 2. So, this is what we will get. 1, negative 4, 27, negative 2. 0, 1, negative 5, and 2. 1, negative 3, 19, and negative 3. Second operation. So here, we got 1, 1. We still have to change get here 1 and get rid of the 1 and negative 3, change it to 0. So I need to change 1 and negative 3, 1 and negative 3 to 0, and 19 to 1. So I should do some more operations. What's the second operation? I'm going to multiply R1 by negative 1 and add it to R3. So if I multiply R1 by negative 1, I multiply 1 by negative 1 and add it to R3, negative 1 plus 1, 0. This is nice. So 1, negative 4, 27, negative 2, the first row will not change. The second row will not change. The third row will change because I will add to it a negative R1. So let's go back, let's look at R1. 1, negative 4, 27, negative 1, multiply it by negative 1. 1 times negative 1 is negative 1. Add it to 1, 0. Negative 4 times negative 1 is 4. Add it to negative 3, it's 1. 27 times negative 1 is negative 27. Add it to 19 is negative 8. And negative 2 multiplied by negative 1 is 2. Add it to negative 3 is negative 1. So we're reaching our goal. We still have to change the 1 to 0 and the negative 8 to 1. Now I will multiply R2, this is R2. I will multiply it by negative 1 and add it to R3 to get rid of this 0 here, to get rid of this 0. So the first row will not change. I will write it as it is. Second row will not change. I will write it as it is. And the third row will change. Minus R2 plus R3. Let's look at R2. 0 times negative 1 is 0. 1 times negative 1 is negative 1. Add it to 1, I will have 0. And negative 1 times 5 is 5. Add it to negative 8, I will get negative 3. And negative 1 times 2 is negative 2. Add it to negative 1, I will get negative 3. Okay. Now, if you notice, let's look at R3. I have 0, negative 3, negative 3. So simply I will multiply R3 by negative 1 over 3. Negative 1 over 3, R3. I will have 0, 0, 1. And I reached the echelon form, I have the diagonals as 1 and the numbers under the 1 are zeros. So I will use the back substitution. What do I mean by the back substitution? Let's look here. Z equals to 1, y minus 5, z equals to 2, x minus 5. Okay, let's go. 1 z equals to 1. 1y minus 5 z equals to 2. 1 minus 4, 1x minus 4y plus 27 z equals to negative 2. This is the back substitution. So I will write it as an equation. Z equals to 1, y minus 5z equals to 2, x minus 4y plus 27z equals to negative 2. So I have z equals to 1. I will use it in the second equation. I will use it here. Y minus 5z equals to 2. That means y minus 5 equals to 2 and y equals to 7. Now I have y and z. I will use it in the third equation to find x. X equals to, we substitute y by 7 and z by 1. We'll have x minus 4 times 7 plus 27 times 1 equals to negative 2. I will do the operation and I simplify it. I will get x equals to negative 1, y equals to 7, and z equals to 1. Okay. Now, if here I use the Gaussian elimination. I use the echelon form. What if I continue and change the matrix to reduced row echelon form and I use the Gauss-Jordan elimination? If you want to perform the Gauss-Jordan elimination, okay, we need to continue. We stopped here. Let's continue. I need to change this triangle here to zeros because in the Gauss-Jordan elimination, the leading coefficient should be 1 and the numbers below it should be 0. In the second row, the leading coefficient should be 1 and the number above and below should be 0. And in the third row, the leading coefficient should be 1 and the number above it should be zeros. Now, so I need to change this triangle, negative 4 is 27 and negative 5 to zeros. So what do? I will multiply sorry for that. I will multiply R2 by 4. Look at R2. I will multiply it by 4 and add it to R1. So because if I multiply 4 by 0, it's 0 plus 1, it will not change. 4 times 1 is 4. Add it to negative 4, it will become 0. 4 plus negative 5 is negative 20 plus 27, I will get 7. 4 times 2 is 8 plus negative 2, I will get 6. So this is the operation. Now, we still have to change the 7 and negative 5 to 1s. So what do? I will use the third row because the third row, it will be our way out, our solution. So I will multiply R3 by 7 by negative 7. If I multiply R3 by negative 7, negative 7 times 0 is 0. Negative 7 times 0 is 0. Negative 7 times 1 is negative 7. And negative 7 times 1 is negative 7. And add it to the first row. So negative 7 times 0 is 0 plus 1 is going to be 1. And negative 7 times 0, 0 plus 0 stays 0. Now negative 7 times 1, this is my goal. Negative 7 times 1 is negative 7 plus 7 is 0. And negative 7 times 1 is negative 7 plus 6 is going to be negative 1. And I reached, this is 0, this is 0, and this is 1. Now, we still have to change the negative 5. So 5r plus r2, I will multiply r3 by 5 and add it to r2. The same thing, 5 times 0 is 0 plus 0, 0. 5 times 0 is 0 plus 1 is 0. 5 times 1 is 5 plus negative 5. It is going to be 0. 5 times 1 is 5 plus 2. It will be 7. Now, this matrix is in reduced row echelon form. We'll get 1x equals to negative 1. 1y equals to 7. And 1z equals to 1. So this is my solution. Okay. Now, if you want to check your answer, you can use your graphical calculator. You can use your graphical calculator Okay, you can use your graphical calculator. What will you do? It's simple. Go to your calculator. One minute. Okay, it's working now. Okay, go to menu, go down to equations, and then press F1. It's 3 equation, 3 unknowns. Okay, let's go back to the augmented matrix in question number 46. Let's go to the augmented matrix in question 46. What was the augmented matrix? It was 2, if you go back, this is 2 equations to unknown, press equation, exits, press F1, 2 equations to unknown, F1. The augmented matrix was 2, 3, 40, 3, 9, and 105. Okay, just fill them up. You'll get x equals to 5 and y equals to 10. X equals to 5 and y equals to 10. Now, going back to number 50. Press exit, please. Exit. And press now F2 because it's 3 unknowns. 3 equations, 3 unknowns. Look at question 50 and look at the augmented matrix. It was 2, negative 8, 54, negative 4, 1, negative 2, 14, negative 1, 1, negative 3, 14, and negative 3. I'm sorry, 19. Let me fix it. 19. Okay. Now, what happened? So you have x equals to negative 1, y equals to z, y equals to 7, and z equals to 1. So this is using the calculator. Okay, thank you so much. Thank you for listening. And if you have any question, please send an email. Be safe and have a nice day.